So you should be on day 5, and your book should be open. There's 2 special cases that you have to be aware of. As you can tell from the past few days, we've been doing a lot of factoring, where you take an area and you write it as a length by a width. For example, x squared plus 7x plus 12. Go ahead. If I had an area of algebra tiles like this, I had 1 square, 7 units, or pardon me, 7 bars and 12 units. You guys know that you could write this as a length and a width. What is this one? You've seen it probably a few times. X plus 4 and x plus 3. Gorgeous. Okay, this is the length, this is the width, and you make an area of what type of shape? Yeah, rectangle. Very nice. Because the length and the width, these 2 factors are different. Rectangle, the length and the width are different. The ones on the whiteboard here, these ones are special cases. Special cases where the length and the width are the same. And instead of having rectangles, you have squares. And that's what they're called. Perfect squares. Okay? So for example, x plus 3, x plus 3. If you were to multiply this, x by x would give you x squared, x by 3 would give you 3x. And then you'd have the exact same thing happening for that one. X times 3 is 3x, and then 3 times 3 is 9. You should be able to recognize perfect squares, like 9 is a perfect square, right? 3 times 3. What if this was 16? This would be 4 and 4. If this was 25, this would be 5 and 5. Okay? And then these 2 middle terms, what do you notice? They're the exact same. So they actually double up. They double up. That's why this formula says twice AB. It's twice AB. Enough with that fidget spinner. Twice AB. Okay? Twice AB. In this case, A and B are the same. So what's twice 3? That's, or pardon me, A is x and B is 3. So 3x is AB. 3x times 2 is 6x. When you collect like terms, you'd have 6x, which is twice 3x. See how that formula works? I don't even recommend that you use this formula. It's just that it's in the back of your mind. Let's try another one. X plus 5 multiplied by x plus 5. Let's just do it the way you guys have been taught, like doing FOIL. X times x, x squared. X times 5 is, and then it happens again, right? 5 times x. And that's the key, that it doubles up. 5x and 5x makes 10x. And the last term would be 5 times 5 is 25. 25 is the perfect square. X squared is the perfect square. Like, what's the square root of x squared? X. What's the square root of 25? 5. And then you write it next to each other. X plus 5, x plus 5. What's 2 numbers that adds up to 10 and multiplies to 25? 5 and 5. So when you do the, what are the 2 numbers that do the multiplying and the adding? If you get the same number, it's a perfect square. Let's try another one that I can just whip off the top of my head. Let's try x squared plus 18x plus 81. Try that one. 9. 9 times 9 is, and 9 plus 9 is 18. So when you get the 2 special numbers are identical, that's when you know it's a perfect square. Okay, let's go through some of these notes and see how many issues we had. So on the first row, which one should I do? The last one? Did you guys do the 4x minus 3? Or did he ask you guys to do that one yourselves? Do it yourselves? Did you guys actually do it? You did? Okay, so did you have a 16x squared? Okay. What was the middle term? Negative 24. And then plus 9. Very nice. Those of you that said 12, you got to do it twice, right? Okay. So what does this mean to be 4x minus 3 squared? What you can do is you can say, okay, it's 4x minus 3 times 4x minus 3. That's literally what a square is. You repeat the base twice. What if this was a 4x minus 3 cubed? You'd have to write another term 4x minus 3, right? The power just tells you how many times you repeat the base. Well, you FOIL it, 4x and 4x gives you the front. And then you have to do the outside and the inside. 4 and 3 makes 12, and then 3 and 4 makes 12 again. Those 12s double up for 24, and they both are negative. So a negative 12 and a negative 12 makes the negative 24. And the last term is negative 3, and negative 3 is a plus 9. Who's got the headphones on? Right here? You gotta take your headphones out, please. Go ahead. Okay, and then we have to go on to now the conjugates. The conjugates are very important. This one is called actually difference of squares. Okay, let's do a difference of squares. That's the second row. Did you guys do all those ones? Is there one that somebody wants me to do? The last one? So let's just do the second row, last one. 2x times 2x is 4x squared. 2x times 7 is negative 14x. Now what happens when you go inside? You get the exact same term, but it's positive. And then the very last is 7 and 7 makes a negative 49 because the signs are different. Now what happens to those middle guys? They cancel. And then you're left with 4x squared minus 49. That's why it's called a difference of squares. That's why it's called a difference of squares. Difference means... What does difference mean in mathematical operations? What does it mean? What's difference? Subtraction. Very good. So you see the subtraction? And then it's a subtraction of squares. Is 4x squared a perfect square? Yeah. What's the square root of 4x squared? What's the square's root for 4x squared? 2x. Beautiful. And what's the square root of 49? 7. Exactly those, right? That's where it came from? I feel like this page is good. You want me to do the very last one on this page? You want me to do this one? Okay, so let's do the FOIL first. 4x by 4x is 16x squared. 4x by negative 7. And then you go inside, you get the exact same thing, but it's positive. And then the very last term is a minus. Those two will cancel because they're the exact same term. One's plus and one's negative. So you have 16x squared minus 49. That's the result of this product, but you still have this negative 3 outside. That needs to now get scaled in, and it will be a common factor being put on to both of those. 16 times 3, I believe, is good. Thank you. And then the next one's going to go out positive because the negative times a negative. So that'll be 147. Beautiful. Did you guys like going in the physics lab the other day? That was good? Okay. I'll get you guys in there again shortly. Did you go ahead. Did any of you guys like this area diagram? Hands up, you liked it. Okay, so different strokes for different folks, okay? Some people are going to like it, some people aren't. How many of these did you guys actually get done? You guys did all of these ones? Are you guys comfortable moving on? Do you want me to do the last one? Okay. So it gets kind of messy when you draw all the arrows over and over again, hey? Okay, so like I'm going to put the first one in the black ink. So I got to take this first term and multiply by all of them, right? Then I got to take the second term and multiply by all of them. And then I got to take the third term and multiply by all of them. Okay, so the first one I'll do in the black ink. A negative times a positive, and then it's going to go to M4. 2 and 2 make 4, right? Now the second one is a negative times a negative, so this term is going to come out, very good, positive. And I got a 4m cubed. And the last one, negative times a positive, so it's just timesing by 1, so it'll stay the same. You guys feel okay about that first grouping? Now I'll do in the red pen the second one. 4 by 5 is 20m cubed. And then negative 8m squared, and then timesing by 1 is easy. Now I'll do the green. I got a negative 15m squared, a plus 6m, and a negative 3. Interesting. Why do I have 9 terms? 3, 6, 9. Why is there 9 terms? Yeah, it's 3 terms by 3 terms. So if you were to draw a grid like this for the one we just did, you'd actually have an extra row here, right? You'd have 3 that way, 3 that way, and then you'd have altogether 9 terms, right? You're never going to be asked to factor anything crazy like that. You'll only be asked to factor ones that end up like this. You'll only end up having to do these ones, where it only fits into 4 spots. Those are the only ones you have to do for factoring. But for expanding, you could get anything crazy like this for expanding. But you'd never have to do any factoring that's this crazy. Anyways, what's the next step here, guys? And I would definitely jot that down, collect like terms, and just like come up with a way to help your brain. Like for me, I strike through the terms once. So I just scan them all. How many M4 terms are there? Only one. So strike through it. But strike through it in such a way that you could look back on it. Like you're not crossing it, so you could never see it again. Now find the cube terms. I got 1 and 2, and is that all of them? So I got to add those together. A plus and a plus makes more plus, so 24. Now jump to the m squares. A minus 2, a minus 8, that makes minus 10, and another minus 15 makes minus 25. I added up 3 negatives, it became more negative. And now I just have the m's. 4 and a 6 make 10 of them. And then the very last is a constant, so final answer. Some of you got that on your own? Okay, that's big success for 10C. If you can do that kind of thing on your own, very strong. Okay? And a lot of students do have lots of success with the expanding. It's the factoring that takes a little bit more of a mental leap, so to speak. Oh, these ones are tough too. These ones are tough because they involve multiple operations. Did you guys have a chance to do any of them? You didn't do any of them. Okay, let's do them together. For this one, I would write bed mass. Bed mass stands for brackets exponents, division, multiply, addition, subtraction. And they actually come in groups. Like to think about bed mass, like always do the brackets first, then do the exponents, and then the division and the multiplication can go together, and the addition and subtraction can go together. So look at this problem underneath. And this is where the math from previous years is going to play in to now, but at the same time, you have to be able to see through the garbage. Like, what is this thing times this thing? What did I just say? It's a times. And then here's a thing times some other thing. That's just a times, separated by a negative, a minus. So what should I do first for BEDMAS? There's no brackets here. It's just multiplication and then a subtraction. Like, what if I gave you this problem? 5 times 4 minus 3 times 2. That would be 20 take away 6, right? Which is 14. This is the exact same problem, just with crazy things looking. Like, this just looks crazier, but it's the exact same thing. This times this, minus this times this. So you have to do those timeses first, right? Okay, let's do that. The first one, you're going to get x squared minus 5x plus 5x minus 5x plus 5x. Do I need to write those, or do they just cancel? And then you get a minus 25 on the last one. I went through quickly on that one, but that product is covered on the previous slide. That's the one with the conjugates, where they're the exact same thing, but one's plus and one's minus. It'll always work out like this, where the middle term disappears, because the middle term is 0. Like, think about this one here. If you were to factor that one, I'll write it up here. It's x squared plus 0x minus 25. Can you guys think of two special numbers that multiply to negative 25 and add up to 0? They are? What multiplies to negative 25 and adds up to 0? Negative 5 and positive 5. That's right here. That would be the factoring for this guy. Okay, so hopefully that's okay for you. And then we have to subtract. What's going to be the answer to this next one? I bet you guys can get good at this. Like, what does 8 times 2 equal? So 16 goes at the end. And then what does 8 plus 2 equal? 10. So this is going to be x squared plus 10x plus 16. You start to get used to these patterns. X squared plus 10x plus 16. And if you don't like that I skip through all that, you're more than welcome to just FOIL it out slowly, and that's fine. Now here comes the hard part. And I would write this in the most boldest words you could possibly write it in. Subtracting brackets. This, by far, for some reason, stumbles so many students every year. Subtracting brackets. The first term, x squared minus 25, is fine. There's like a positive 1 out here that you don't see. Like, you don't need those brackets actually for that thing. Like, if you multiplied by positive 1 in here, nothing would change, and you'd have x squared minus 25. It's the second term that's crazy. This is actually like a minus 1 coefficient. So when you multiply all these by minus 1, what happens? All the signs will, SIGs, signs change. Do you remember when we were factoring a negative out and the signs changed? This is no different when the negative goes in and the signs change. Jackson, just try to get him quickly, please. He'll be back, right? Okay, please just try to go as quick as possible. Okay, so all these signs are going to switch. So x squared becomes minus x squared. 10x becomes minus 10x, and negative 16 becomes positive 16. Oh, I screwed up. It was positive 16 from the beginning, right? Thanks for catching that. Sometimes I get thinking about all this stuff and then I make little mistakes. Okay, now you can collect like terms. What happens to the squares? Cancel, good. And then you're left with a negative 10x and a negative 41, good. And notice how I put them in the descending order, like the x goes first and then the constant. That's a convention. So I feel like I will do the one underneath, and then we'll go to the lab to do these other three. Because you guys haven't done this one or this one, right? You haven't done them? Okay, so let me do the one underneath, and then you guys can go to the lab and work on those other ones. I just want to show you this one with the square. The one underneath. Okay, and then you guys can go to the lab and do some practice. All right, so here we go. Before we just jump into the foiling, you have to analyze the structure. You have a product subtracting a product with exponent. Interesting. Interesting. We can do the product separately, so let's do that. 2x by 3x, 2x by 4, minus 1 times 3, and minus 1 times negative 4. Wrap that in a bracket, because that's the result of the first product. And I'm actually just going to clean that up before I move on, because 8x take away 3x is 8x take away 3x is 5x. Now I'll move on to the second part of this problem. If you see a power, I want you to write it twice. This step is crucial. This power 2, you write the base 2 times. If it was power 3, you'd have 2x minus 3 3 times. If that was a 4, you'd have 2x minus 3 4 times. If that was a 5, you get my point? Now, what do we do when we have a coefficient times a binomial times a binomial? Does the coefficient 4 negative, does it go into both, or does it just go into 1? Into 1. And I would actually do it last, because it's really easy to put the 4 in. Just times everything by 4, right? That's really easy. Do the FOIL first, because if I put the 4 in there, then I have an 8, and then it's 8 times, it's just easier to do these two because they're simpler. So just take care of that. So you leave that 4 on the outside, and let's put the answer to the red box in this bracket. And let's stay super organized with brackets like this. Okay, let's go. 2 by 2, 2 by negative 3. And then it happens again because it's a perfect square, and it actually just doubles up. Minus 6 and minus 6 doubles up to minus 12. It doubles up. And then the very last term is a negative times a negative, which is always positive. And I know it gets a little bit annoying rewriting it over and over again, but it does actually help you stay organized. Can I just go minus 6 is minus 12x? Is that easier than rewriting it all over again? Okay. Now this minus 4 is going to come in and hit all these. So what happens when you minus or you multiply by a minus? Sign change. So put that again somewhere in your notes there, like sign change. And at this point, we no longer need the brackets. When you distribute through, you don't need the brackets. And that can be confusing at times for students, like when do I need brackets, when do I not need brackets? But hopefully with more and more practice, you start to see it. Minus 16x squared plus 48x minus 36. So if your mental math isn't quite there, I'll just give you a few seconds to catch up. I got a 4 by 4. 4 by 4, that gives 16. A negative times a positive is a negative. Then I got a 4 by 12. So 12, 24, 36, 48. And a negative make a positive. And then 4 by 9 makes 36. And a negative times a positive is a negative. And now you can collect like terms. Positive 6. Whoops, my bad. Positive 6 and minus 16. Negative 10. Positive 5, positive 48. Good. And then minus 4, minus 36.